Welcome to the Project 3b walkthrough. Today we're going to be demonstrating how to use our project and what our project is about. So our project uses heap, quick, insertion, and hybrid sorts to sort through real-world data about police shootings, and it sorts according to age, city, state, or race, and it sorts according to whether the user wants ascending or descending sorts. And so we'll get right into it. So first, let's test invalid input. We'll try no, and it asks it again. So we'll do age, and we'll do ascending first. So here's the output for each sort. It goes from least to greatest, and it takes this long, this long, this long, and this. Now we'll try it for descending. As you can see, it prints from greatest to least now, and it takes this long for heap sort, this long for quick sort, this long for insertion sort, and this long for hybrid sort. Next, we'll test the cities, and we'll do ascending first. Here's the time that it took for the heap sort, 40 seconds. We'll move on to quick sort. Quick sort took significantly longer, clocking it in about 99 seconds. We'll move on to insertion sort. Insertion sort took significantly less long, 11 seconds, and we'll do hybrid sort. As you can see, hybrid sort also took a long time, about 107 seconds. Next, we'll do city descending. Here's the time for quick sort. Here's the time for insertion sort. And here's the time it took for hybrid sort. Next, we will sort by state, and we'll start with an ascending sort. So here's the heap sort, here's the time for quick sort, here's the time for insertion sort, and here's the time for hybrid sort. Now we'll try state with a descending sort. As you can see, this time it prints from greatest to least, and here's the time for heap, here's the time for quick, here's the time for insertion, and here's the time for hybrid. Next, we'll move on to the final category, race. We'll start with an ascending sort. It goes from least to greatest with this amount of time, this amount of time, this amount of time, and this amount of time. Now we'll do race descending. And it goes from greatest to least in this amount of time for quick sort, this amount of time for insertion sort, and this amount of time for hybrid sort. So as you can see, the time for the sorts in each category were approximately the same, except for the city category, where insertion sort was noticeably faster, with a sorting time of about 11 seconds versus the other sorts, which had an upward of 100 seconds. This is because the time complexity for the insertion sort is O of n log n, while the other functions have a complexity of O of n log n squared, where n represents the number of unique elements. If you do the mathematical calculations, you can see that a small value for n does not change the value of log n that much, which explains why the times for age, state, and race categories were so similar. However, n had a value of nearly 3,000 for the city category, which explains why n log n had such a large difference to n log n squared. This concludes the presentation of our Project 3b program. Thank you.